Hey classes, welcome. If you check out the board behind me, we're going to jump through some of the things that we saw in class the last 2 days. I thought I'd wait until the first full day to make sure we got everything in that we wanted to in terms of the procedures, what the class looks like, what the seating looks like around the room. And I try and put out once in a while little 10-minute recaps on anything you might have missed in class. Also, we always put up the notes at pacificascience.org and on your Google Classroom as soon as possible after class. So let's jump on in. I'll try and keep it quick and to the point today. For day 2, week 1, we went through what you need for the class. Of course, the seating charts were up there the first day. The next day, they were up there without the numbers on them because I write them on the whiteboard, trying to save a little paper there. The row is your lab group. And I switch those up about once per month. So over the course of the school year, you'll get about 9 different seats in the room randomly. You see me randomize it. If anyone needs a special seat in the front because of being able to see the board a little bit better, let me know. But even then, it's okay if you're a little bit further from the board because we usually, most days, get up and we have a lab activity or something that takes us around the room a little bit. When you look at what we need in class, scissors, glue sticks, and colored pencils are there because, and I'll reach over here and grab an older one, we keep an interactive student notebook, a science notebook. They call it interactive, of course, because the data that you get in it. For example, today, we get the dimensions of our classroom in meters and cubic meters, and the dimensions of our classroom are your data for this lab experiment. And also, it might be a little bit different than somebody else's data. That's what we want in this class. We want to be able to compare data. We want to be able to compare what's in our notebooks. A regular spiral-bound notebook is fine. I used to require big binders. If you want to use a binder, you can. It could be a section in another binder. Just make sure it's a regular size 8.5 by 11 binder, something that can accommodate those sheets. Because a lot of times there'll be something to, like a data sheet to cut out and paste on down in there. And then later on, when we have our weekly tests, which will start next Friday, we have our online tests, and you can use your data sheets. You're asked to use your data sheets to see what we have in terms of the results of the experiment. Moving on from there, usually 2 pages per day. For example, today this is 1 page. That's the other page over there. And it's not all about just sitting down and writing things down. But I do want students to write things down because the actual act of writing has been shown to increase comprehension. It's a little bit like I gave an example in one class today that is like baseball practice. Locally, I used to do a little bit of coaching here with baseball. If you were just to go to baseball practice and sit there and the coach were to talk to you about perhaps overrunning first base. You can overrun first base, but you can't do it with second and third. You have to stay on those bases. And they were going to give you a lecture on overrunning the base, making sure you stay on the baseline. So if you turn in, they don't throw you out, that sort of thing. And they say, okay, we're done for the day, let's go home. That'd be kind of a silly practice. What you end up doing, of course, is then after they talk about it for a little bit, that's the first 10 minutes of the class, say the lecture part, you actually do it. You actually practice, you spend a little time on the bases and you check it out. That's what I want the students to do, to physically do the writing, the data gathering. For example, there was a good law school study a while ago where they were using computers to take pictures of the board and to do notes by typing. Turns out that comprehension went way down when you're just asked to even type and take the pictures and then look at them later. Comprehension went back up when you started writing down what was physically on the board, actually writing down the notes by hand, because the actual act of using the auditory system, hearing the notes, seeing the notes, and then physically writing them helps you remember them better. So that's why we do it in class. And it's good practice. Penmanship is always important across the board. And if you're looking at today's subject, where we're jumping in, chapter 1, and also the beginning of most science classes, is measurement. We're throwing out a lot of numbers that the students write in the first day or two. Really, I'd say this class is like a history class. It's a history of the universe from 14 billion years ago, roughly, until now. But I always encourage students to question that sort of thing. Like, okay, I just had to renew my driver's license, and how does that fit in? Well, renewing the driver's license, I had to change the hair color from brown to gray. Yes, age is catching up with me. But if you check out that, you say, okay, you're gray, Mr. Forbes, you might be 55 years old now, but you're not 14 billion years old. How do you know the universe is really that old? I want you to think like, okay, it's one thing to diligently write down the notes, but part of science is to question these things. Okay, how do you know that? And science is all about, okay, now we've got this fact written down, let's go and look at the evidence. How does the evidence support that? How do our observations and our measurements support the idea that the universe is really that old? That's the heart of science. Yesterday, one of the notes we had on the board, there are two kind of silly ones, and one that was a little bit more serious. We talked about things like Bigfoot and UFOs, right? The silly things that you might see on TV. They have YouTube channels all devoted to that sort of thing, saying, oh, well, yeah, I think, ancient aliens helped build the pyramids, or that Bigfoot exists in the northern forest, both of which are really wild claims. And it's fine to make claims like that. People can do that all the time. It's encouraged to make claims, but then it's on the onus of that person to provide the evidence for that sort of thing. That's what science is all about. Where's the evidence? There was another claim that was also talked about. It wasn't written on the board. It was a note before. It didn't have a cartoon with it like I usually draw. It was about a guy who lived about a century ago by the name of Alfred Wegener. He had this amazingly wild idea that the continents moved. And people ridiculed that at the time. They said, well, that's ridiculous. How can a whole continent move? Turns out, of course, plate tectonics is a real thing, and he was bang on correct. And he had the evidence to support that. He didn't, unfortunately, in his lifetime see that evidence come into wide acceptance, but the evidence about fossils being found in different continents that match up with each other, the seafloor spreading, which we'll talk a lot about this year, all of those things, one, were evidence to support the idea, and two, are things we learn about in this class, because when we're learning about evolution, when we're learning about biology, which is the focus of 7th grade science, it touches on all of those things. We have to know a little bit about chemistry, a little bit about physics. We have to know quite a bit about geology, because the evidence for evolution lies in the fossil record. And those are all things that we talk about here in 7th grade science, which I absolutely love. Moving on from there, we talked a bit about the metric system, the difference between the metric system and the imperial system that America still uses. I'm always a little apologetic when I talk about this in class, because when I was in 8th grade, 7th grade, they always said that the metric system would be completely in use by the time I was an adult. I think I'm an adult now, but the metric system is still not used across the board in the United States. We gave the example also of the Mars Polar Lander, which unfortunately crashed on Mars. This is a robot mission, but it crashed because part of the computer engineering team that wrote the program for this used the Imperial system, part used the metric system. And when this thing came through the atmosphere of Mars, it went far too fast, crashed on the South Pole. This was around 1999-ish when I was working down at my student teaching job. So I've been teaching for about 20 years now down at St. Craig in San Mateo, famous for the graduation spot for Tom Brady, who went on to Sarah High School and then fame in the NFL. We were waiting for the information on what happened to the Mars Polar Lander, and the information never came through. It turns out that because of a mistake of one team using the Imperial system, one team using the metric system, the Mars Polar Lander crashed. So that's one of the quick examples, kind of a classic example now, of the importance of having a standardized measuring system. And hopefully in the United States we'll get to a standardized metric system across the board. Moving on from there, I'm going to go switch the boards here for a second. I'm also tethered to my computer, so I'm going to reach over here. From there, I went to these notes. Let me get to the right spot, somewhere around there. We went to these notes on the prefixes that we use, of course, in the metric system. It's such an easy system because you're just hopping decimal places. Tomorrow we're going to talk a little bit about this too in terms of the size of the entire universe, the number of stars in the universe. But when you're hopping decimal places, it's really just adding, taking away zeros, if you want to think about it that way. Anyone who's done any shopping for technology, you've seen tera, giga, mega, kilo, centi. Also, when you're talking about the technology leaps in the last couple of years, it was a big deal. Behind this board over here, I've got my old Macintosh that I still have from 1999. It still works. It's an old iMac, and it was a really big deal when they finally got a Macintosh that had a gigabyte of memory on it. Now, of course, they talk about terabytes. They have small devices that can easily hold a whole terabyte of information. So the technology, we're always updating the technology, and that's allowed us to see deeper into the universe. We're going to be checking out some pictures from the Webb Space Telescope tomorrow. And finally, volume, mass, and length are, of course, the big three that we measure with the metric system: the liter, the gram, and the meter. Very important for when we're making our measurements here in class. And to keep me to 10 minutes, I'll just kind of wrap up by saying our lab activity today with our groups was to measure two things. a flat surface, a two-dimensional surface, which was our desk. The length times the width in centimeters. And then they were challenged to get up with their lab groups, walk around the room with a meter stick, which I have over here. My 7-iron here is about a meter long, and estimate the size of this room in cubic meters. And this room, I'm not going to pick up the camera and go around, but it's got a vaulted ceiling here. So it's a little bit challenging regarding the ceiling. That is getting into the estimation part of the lab. Students are going to be asked to, quite a bit through this class, estimate values, which is really important in biology and science. So that was a quick recap of where we've been the last 2 days. Really just 2 pages of notes. If you were here on the first day and had a notebook, there's 4 pages total, but really the first 2 pages were what we recapped back here on the materials and the way most of the class is going to look. Remember, 2 pages of notes per day, 2 whiteboards, and then we try and do an activity or something that goes along to support that, and a test every Friday. Looking forward, so forward to, I absolutely love the subject, and of course I'm looking forward to 179 more days of exploration with the class, 179 more days of learning with you guys. So take care, see you online and see you here in the classroom, and I will talk to you soon. Bye-bye.